All right, this is Unit 2, Lesson 5, Completing the Square. So our essential question is, how can you solve a quadratic equation by completing the square? And at the end of this lesson, you can solve quadratic equations by completing the square. All right, so example number 1 says use square roots to solve quadratic equations. What are the solutions of 25 equals x squared plus 14x plus 49? Okay, so previously you solved a simple quadratic equation by finding the square root of both sides. You can use a similar method to solve more complicated quadratic equations. Okay, so I have x squared plus 14x plus 49. So I'm rewriting the original equation. I have x squared plus 2 times 7 plus 7 squared. So I recognize that the quadratic expression is a perfect square trinomial. Okay. So that means 49 has a square root, which is 7. So 7 squared is 49. And I know that 2 times 7 gives me 14. That's what makes it a perfect square trinomial. So I can do 25 equals x plus 7 squared. I can square root both sides, which gives me 5 equals the absolute value of x plus 7. So plus or minus 5 equals x plus 7. So 5 equals x plus 7, or negative 5 equals x plus 7. So x will equal negative 2, or x will equal negative 12. So solutions of 25 equals x squared plus 14x plus 49 are x equals negative 2 and x equals negative 12. Okay. So let's try it out. We want to find the solution to the equation 81 equals x squared plus 12x plus 36. I can notice that 36, if I square root that, that's 6 squared. So I have 81 equals x squared plus 2 times 6x plus 6 squared. So that equals 81 equals x plus 6. Okay, you can always double check x plus 6 squared. You can always double check that x plus 6 squared is in fact x squared plus 12x plus 36. I'm multiplying x plus 6 times x plus 6. I'm going to take the square root of 81 and the square root of x plus 6 squared. That gives me 9, so plus or minus 9 equals x plus 6. So that means 9 equals x plus 6, or negative 9 equals x plus 6. This is an absolute value. 6 is an absolute value. When I solve these equations, I subtract 6 from both sides, so that's 3 equals x, or negative 9 minus 6 is negative 15 equals x. So negative 15 or 3. All right, when I'm looking at B, I have 9, again, at the perfect trinomial, minus 8 times 2x plus 8 squared. When I break this down, this equals x minus 8, because this negative 16 is a minus sign, so minus 8. Notice here it's a plus, so it would have been plus squared. Again, you can always double check x minus 8 times x minus 8. I'm going to take the square root of 9 and the square root of x minus 8 squared. When I do that, I get plus or minus 3 equals the absolute value of x minus 8. Okay. That gives me 3 equals x minus 8, or negative 3 equals x minus 8. I'm going to add 8 to both sides, so that gives me x equals 11, or x equals 5. Negative 3 plus 8 gives me 5. All right, So understanding the process of completing the square, how can you complete the square to write an expression as a perfect square? So how can you rewrite the expression x squared plus bx in the form x plus p squared? Okay. So not every quadratic expression is a perfect square trinomial. So completing the square is the process of finding the constant to add to x squared plus bx to create a perfect square trinomial. So the model below depicts the process of completing the square. So model is x squared plus bx. So here's x squared plus bx. I divide bx in 2 halves. Okay. Then I find the missing value to complete the square. So x plus b over 2. Okay, so the sides of the missing square are b over 2. The area of the square is b over 2 squared. Then I write the equation. To create a perfect square trinomial, add b over 2 squared to the variable expression. So x squared plus b over 2x plus b over 2 squared. Okay. So how can you complete the square to write an expression as a perfect square? So write x squared plus 8x plus 5 equals 0 in the form x plus p squared equals q. So the first thing, x squared plus 8x plus 5 equals 0. So I rewrite the original equation. I'm going to move my 5, my value with no x, to the other side. So x squared plus 8x equals -5. So I'm isolating the variable expression. And then I'm going to determine the constant needed to complete the square. Okay, so I'm looking at 8x. If I divide that by 2, that's 4. And then 4 squared is 16. So b over 2, so 8 over 2 squared is 16. So that means my equation is x plus 4 squared, and I added this 16 to the other side to keep my equation equal. So that's 11. So x plus 4 squared equals 11. So the equation x squared plus 8x plus 5 equals 0 can be rewritten as x plus 4 squared equals 11. All right. So I know that this can be kind of confusing until you've done it a couple of times. So let's take a look at an example. So how can you write the equation x squared minus 6x minus 11 equals 0 in the form x minus p squared equals q? So the first thing that I want to do is I'm going to rewrite this expression. It's set equal to 0 right now. I want to have all the x's on one side and all my constants on the other side. So in order to do this, I need to add 11 to both sides. So I have x squared minus 6x minus 11 plus 11 equals 0 plus 11. So this gives me x squared minus 6x equals 11. Okay. Now, what I want to do is I know that I have to divide 6 by 2 and then square it. So 6 divided by 2 . 6 divided by 2, and it's a negative. Negative 6 divided by 2 equals -3. Okay. I then need to square that. So -3 squared equals 9. So I need to add 9 to both sides. So I have x squared minus 3x minus 6x plus 3 squared equals 11 plus 9. Plus 9. Okay, so now when I rewrite this, remember I had this minus sign here, so that means it's going to be x minus 3 squared 11 plus 9 equals 20. So x minus 3 squared equals 20. So I take the middle number, the x value, I divide it by 2. I square that. That is what I'm adding to both sides. Okay. That number, so in this case, 3, -3, becomes what my x minus value is, or x plus value is. Okay. All right, so example 3, solve a quadratic equation by completing the square. How can you solve 0 equals x squared minus 2x plus 3 by completing the square? So again, I'm going to take this, negative 2 divided by 2 gives me negative 1. Okay, so I'm going to add 1 to both sides. So x squared minus 2x plus 3, I'm going to take this 3 and I'm going to move it over here. Negative 3 equals x squared minus 2x. Negative 2 divided by 2 gives me a positive 1, or negative 1. So I add 1 to both sides. So negative 3 plus 1 equals x squared minus 2x plus 1. So I get negative 2 equals x minus 1 squared. From there, all they did was they just solved for x. Okay? So I square root both sides. This is a negative. So remember back to our imaginary numbers. A negative square root of a negative 1 gives me I. So plus or minus I, square root 2 equals x minus 1, and then I add 1 to both sides. So I get 1 plus or minus I square root 2 equals x. So solutions of 0 equals x squared minus 2x plus 3 are x equals 1 plus I square root 2, and x equals 1 minus I square root 2. All right, let's try it. Solve the following equation by completing the square. I have 0 equals x squared plus 4x plus 8. Again, I want to move that 8 to the other side. So I'm going to rewrite the equation first. It's always important that you rewrite the equation, because if you rewrite the equation incorrectly, then your whole problem's wrong. Okay, I'm going to move 8 to the other side. Okay. Now I'm going to complete the square. So 4 divided by 2 equals 2. 2 squared equals 4. So I'm adding 4 to both sides. So negative 8 plus 4 equals x squared plus 4x plus 4. Negative 8 plus 4 is negative 4. So that equals x plus 2 squared. I remember the root of 4 is 2. That's where we got the 2 squared right here. Okay. From here, I'm going to square root both sides. So I'm going to take the square root of negative 4 equals the square root of x plus 2 squared. That gives me plus or minus I plus or minus 2I equals x plus 2. I'm going to subtract 2 from both sides, so I get negative 2 plus or minus 2I. So that means my solutions are negative 2 plus 2I or negative 2 minus 2I. Next, I have 0 equals x squared minus 8x plus 17. So I'm going to rewrite my equation. And then I'm going to move that 17 to the other side. So I get negative 17 equals x squared minus 8x. I'm going to divide negative 8 by 2. That gives me negative 4. And then I'm going to square that to 16. So I'm going to add 16 to both sides. So negative 17 plus 16 equals x squared minus 4x plus 16. So this gives me negative 1 equals x plus x minus 4 squared. I'm then going to solve for x. So I'm going to take the square root of negative 1 and the square root of x minus 4 squared. Okay, so this gives me plus or minus I equals x minus 4 squared. Sorry, just x minus 4. Okay. I'm going to add 4 to both sides, so I get 4 plus or minus I equals x. 4 plus I or 4 minus I are going to be my solutions. Complete the square to solve a real-world problem. Libby plans to create a rectangular pasturing enclosure. She has 340 meters of fencing available for the enclosure's perimeter and wants it to have an area of 6,000 meters squared. What dimension should Libby use? So let L and W represent the length and width of the enclosure. So the perimeter is 2L plus 2W equals 340. So 2W equals 340 minus 2L. And I divide both sides by 2, so I get W equals 170 minus L. So Libby wants the area to be 6,000 meters squared. Write this as an equation. So 6,000 is A equals L times 170 minus L. So when I multiply L through, I get 6,000 equals 170 L minus L squared. Okay, this is just like we would be using for a quadratic equation. I want my L squared to be positive, so I just flip everything over. So I get L squared minus 170, L equals negative 6,000. Okay. I'm going to complete the square. Okay, so negative 170 divided by 2 is negative 85. Negative 85 squared is 7,225. That's where they got this number from. Remember, all you have to do is take this middle number, divide it by 2. Okay? And then square that, that's what you get. So L minus 85 squared equals 1,225, is negative 6,000 plus 7,225. So L minus 85 equals plus or minus 35. So L equals 85 plus or minus 35, so L equals 120 or 50. So when L equals 120, then the width equals 170 minus 120 or 50. And if the length is 50, then the width is going to be 120. In each case, there is 2 times 120 plus 2 times 50 or 340 meters of fencing used. Likewise, the area is 120 times 50 or 6,000 meters squared. So Libby should make 2 sides of the enclosure 120 meters long and the other 2 sides 50 meters long. All right, so let's try it. The relationship between the time since a ball was thrown and its height can be modeled by the equation h equals 32t minus 16t squared plus 4, where h is the height of the ball after t seconds. Complete the square to find how long it will take the ball to reach a height of 20 feet. All right, so the first thing that I want to do is I'm going to rewrite the equation. So 20 feet equals 32t minus 16t squared plus 4. Okay. So in order to do this, I need to rearrange this a little bit. So I'm going to move the 16 here, t squared minus 32t equals negative t minus 4 equals negative 20. I'm going to add 4 to both sides. 16t squared minus 32t equals negative 20 plus 4. So that gives me 16t squared minus 32t equals negative 16. Now, the other thing is this 16t squared, that's not normally what I use in order to complete the square. So I actually need to divide everything, the entire equation, by 16 because I need 1 to be my coefficient for t squared. So when I divide everything by 16, so 16t squared minus 32t equals negative 16, and I'm dividing it by just happened. divided by 16. I'm going to divide each of these by 16. So when I do that, 16 divided by 16 is t squared. 32 divided by 16 is 2t. And negative 16 divided by 16 is negative 1. Okay. To complete the square, I take negative 2 divided by 2, which is negative 1. So I have t squared minus 2t plus 1 equals negative 1 plus 1, which is 0. So t squared minus, so I can rewrite this as t minus 1 squared equals 0. I square root both sides. The square root of 0 is 0, so I have t minus 1 equals 0. I add 1 to both sides, so t equals 1. So after 20 feet, so it will take 1 second for the ball to reach a height of 20 feet. All right, so example 5, write a quadratic equation in vertex form. So I want to write the equation y equals negative 2x squared plus 10x plus 1 in vertex form and then graph it. What is the maximum or minimum value of the graph of the equation? So y equals negative 2x squared plus 10x plus 1. I want to subtract 1 from both sides. So y minus 1 equals negative 2x squared plus 10x. So y minus 1, I factor out that negative 2, negative 2, x squared minus 5x. Okay. So then I have y, remember I complete the square, so b squared, which is the 5. So negative 5 divided by 2 squared equals 2.25, or 6.25. So y minus 1 minus 2 times 6.25, remember that negative 2 is out here, equals negative 2 times x squared minus 5x plus 6.25. So that's y equals negative y minus 13.5 equals negative 2 times x minus 2.5 squared. Okay, so remember negative 5 squared is 2.5. So y equals negative 2 times x minus 2.5 squared plus 13.5. I solve for y. So the graph of this equation is a parabola that opens downward, so it has a maximum of y equals 13.5 at x equals 2.5. So the negative, remember this minus sign, that tells me the parabola opens downward. It's squared, that tells me it's a parabola. My maximum height is this, the 13.5, because it's opening downward at x equals 2.5. So the vertex of the parabola is 2.5, 13.5. So here's my parabola. Let's try an example. 5, write each equation in vertex form, identify the maximum or minimum value of the graph of each equation. So let's start with this. So I have y equals negative 3x squared minus 9x plus 7. So y equals negative 3x squared minus 9x plus 7. I want to subtract 7 from both sides. Negative 3x squared minus 9x. Okay, when I do this, I need to factor out this negative 3 because I don't like it there. Negative 3x squared. Negative 9 divided by negative 3 is positive 3x. From here, I need to complete the square. So b squared, or b divided by 2 squared. So that's 3 divided by 2. Equals 1.5 squared equals 2.25. So I have y minus 7 minus 3 times 2.25 equals negative 3 times x squared plus 3x plus 2.25. Okay. So when I do this, 3 times 2.25, 6.75. Oh, that's supposed to be y. Y minus, and then, all right, so 3 times 2.25 is 6.75, and negative 7 minus 6.75 gives me negative 13.75 equals negative 3 times x plus 3/2 or 1.5 squared. 1.5 squared. I need to add 13.75 to the other side to get y by itself. So I get y equals negative 3 times the quantity x plus 1.5 squared plus 13.75. So this is a parabola which opens downwards. So has a maximum of 13.75. The vertex is at, so 75 when x equals negative 1.5. Remember, our vertex form has a minus sign in front. So this was a plus, so we needed to flip it. So when x equals negative 1.5. So that means the vertex is at negative 1.5, 13.75. So here's my equation. Maximum is 13.75 when x equals negative 3.2, or 3, which is negative 1.5. All right, B, y equals 2x squared plus 12x plus 9. So I'm going to rewrite my equation. Okay, so I'm going to subtract 9 from both sides. So y minus 9 equals 2x squared plus 12x. Okay. From here, I'm going to complete the square. So I have, I need to divide. I do. Minus 9. I need to factor out a 2 plus 6x. Now I need to complete the square. So I have 6 divided by 2 squared equals 3 squared equals 9. So I have y minus 9 All right, so I have y minus 9 plus 2 times 9 equals 2x squared plus 6x plus 9. And when I do this, I get y plus 9, because 2 times 9 is 18, minus 9 is 9, equals 2 times x plus 3 squared. And then I need to subtract 9 from both sides. So I get y equals 2 times the quantity x plus 3 squared minus 9. So this means it's a parabola opening upward that has a minimum of 9 at x equals negative 3. So the vertex of the parabola is negative 3. Negative 9. All right, so Concept summary. The rectangles showing x squared plus 10x are arranged into a square. So I split the 10 into 5x and 5x, putting one here, and then this little green tiny section is what I need to add in order to complete the square. The square has side length x plus 5, so the number needed to complete the square is 25. The number needed to complete the square is half the coefficient of the middle term squared. The middle term coefficient is 10, half of 10 is 5, and 5 squared equals 25. To solve x squared plus 10x equals 3, I add 25 to both sides of the equation, take the square root of both sides, and solve for x. X squared plus 10x plus 25 equals 3 plus 25. So x plus 5 squared equals 28. And then I square root both sides, so I get x plus 5 equals plus or minus 2 square root of 7. 4 times 7 gives me 28. Square root of 4 is 2, and square root of 7 is 7. The square of 7. So x equals negative 5. I subtract 5 from both sides. X equals negative 5 plus or minus 2 square root of 7. And that is the end of Unit 2, Lesson 5.